Okay, hello everyone. Thank you for joining this session. In today's session, we will go a bit on the details. So, not too in-depth details because that will take some time, but just to share the connections or the integrations that you can do with from AutoCAD to Inventor and to AutoCAD again. Okay, so basically moving forward from 2D drawings to 3D drawings is one thing, and then what's more? Okay, what you can do more, not just the normal 3D modeling. So let's see what we can do more. Okay, so in summary, so basically AutoCAD and Inventor integration capabilities. This is I have summarized it into the simplest form. So basically, from AutoCAD to Inventor, basically importing a 2D drawing with or 2D to 3D conversions. Okay, AutoCAD to factory design utilities where we can use AutoCAD 2D layouts, which a lot of companies are using AutoCAD to plan their factory layouts. Okay, so we can bring that layout into factory design utilities to enhance the factory design efficiency. So we can simulate the placement, positionings of factory equipments and so on. Okay, and then from AutoCAD 2D drawings to maybe 3D models of a sheet metal or maybe just 3D model of any parts. And then you will require some cutting optimization. Basically, you need to do a laser cut to cut the raw material into shapes so we can plan the cutting optimizations so that we can plan and help to cost saving and reduce the material usage. Okay, shared view collaboration. So basically, you can share your design via clouds. Okay, a lot of my customers are not aware that their AutoCAD and their Inventor are able to share directly from the platform. Okay, beam interoperability. So nowadays, there's a lot of factories or companies where their products are being used in constructions. Okay, so like building equipments, okay, like elevator, escalator, and so on. Okay, so that's the beam interoperability, so that we can plan how do we make it easy to send our products, models, or drawings to be used or to be consumed by the BIM people. Okay. All right, so a bit of the workflows. Okay, so this is as simple as I can go in. So when we talk about plant design, so of course you have your plant modelings. Okay, you have your MEP services. Okay, so all your ducting and so on. Okay, PNID drawings, so AutoCAD for piping and spool drawings, and Inventor can be used for equipment design. Okay, so when we talk about integration between the two, so this is one of the sub segment in manufacturing industry where AutoCAD is being used quite extensively. Okay, for pipings, for structural designs, for MEP, and also for PNID. So when we go to example of some equipment design, so usually everything start with AutoCAD 2D. Okay, so usually customer or usually companies or engineers have old 2D drawings or existing 2D drawings where they want it to be more intelligent. So where then the next step always they need to go in towards 3D model where they make their design more parametric so that it allows them to automate design so that they can be more productive and faster. Okay, and then the ability to create constructions drawing or detailed drawings at maybe a fraction of the usual time, probably quarter of the usual time by compared to 2D drawings. Okay, we can use the 3D models that were created with the integration from AutoCAD 2D to Inventor 3D. We can use it for FEA simulations to do a stress test. Okay, and then we can do skid design example, and then integration between all these equipments with piping design and skid designs. Okay, so AutoCAD to Inventor connection. So very simple. So the common ways of common workflow, common flow is, so when we open an AutoCAD drawings, so any existing drawings, and then we want to move forwards to a more modular design, a modular 3D design. Okay, so we can as simple as copy and paste AutoCAD drawings, go into Inventor and paste it. Even Control C and Control V also works flawlessly for this process. Okay, on top of getting in or copy the drawings from AutoCAD, Inventor also are able to open a lot of file formats, all the famous file format from all third-party 3D modeling software are supported within Inventor. Okay, so and then usually customers or usually engineers, they will analyze their layouts or their products or their equipments with their existing 2D layout, whether all is matched or all aligned. Okay, an example that we have here is, let's say this is an AutoCAD interface. So let's say I have a so-called tank. So a tank drawings. So from a tank drawings, so before I go towards 3D, so in AutoCAD existing drawing, we have a lot of information. So we need to identify and we need to specify whether we want to carry all the information over or we want to use just a certain portions of the drawing profiles. So in this case, from that AutoCAD just now, I just copy, okay, and then into Inventor, and I can just paste it, okay. Even Control V also. Okay, even Control C and also Control V also work flawlessly here. Okay, so in AutoCAD, so all the dimension is not parametric. It's basically it's just a text. But when you copy into Inventor, all the dimensions that were copied from AutoCAD earlier becomes parametric automatically. So you see now that dimension that was copied over from AutoCAD now becomes parametric. So we can just double click the dimension and make changes to the value, and our profile will automatically changes and update accordingly. Okay, so you can see that the height was previously from AutoCAD dimension. We copied, and now it works as a parametric dimensions in Inventor. Okay, so these integrations, okay, so because they are under the same brand or same principle, so they share the technology, so we can easily copy and paste, and we can reuse all our existing drawing with very minimal redrawing is needed. Okay, so from here we can just, and then after we have created all the profiles, so we can give pictures to make it 3D models. All the dimension that was key in the process is stored under parameters. We can assign our own, or we can create our own parameters so that it's easier for us to manage it in a later stage. So in this case, I'm just creating a few of user parameters where later on I can easily manage them. Okay, so from the original dimensions that was with value just now, so now I can assign them to my parameter, the one that I just created earlier. Okay, so from there, what now I can do, I can assign height, and then let's see, it's updated. And then whenever we want to control the size, we no longer have to go in and see all the numbers. We can just go to our user parameters and make changes to the parameter that we already created in the user parameters. Okay, so that's basically the quick and fast way to explain the conversion from 2D to 3D. Okay, so understand that this kind of equipment is not just one part. So it comes with a lot of accessories and supporting components to support its functionality. Okay, so imagine that we already created a lot of or multiple components. Okay, and then what we need to do next is to and then assemble them. So basically the idea is, or the process is, so from parts, after you create parts, you create assembly, and then you assemble all the parts within assembly. So now we bring in all the parts that were created separately, we do this assembly, and we assemble them. Okay, so along the way, so if you plan correctly, so we can reuse all our parameters. Earlier, you saw that I created a user parameters to control the tank size. So we can also use the same method to control the whole assembly. So now you can see that now I can control the shell, or the shell of the tank. Okay, the diameter of the nozzle, the location of the nozzles, so the angle of the nozzles. Okay, so all that can be controlled from just a form. Okay, so with this method, or this usage of form, even your salesperson are able to make amendment to the components, and then they are able to generate a part list or bill of materials by themselves. Okay, so that they won't spend their time asking all the updates, all the changes from you. So they can make the changes. But as an engineer, you need to limit, or you need to control, or you need to identify what can be changes and what cannot be changed. Okay, so done with the assembly. So now I want to create a detailed drawings of the 3D models. So now after all the assembly is done, so I bring all the assemblies into my so-called Inventor drawings. Okay, so Inventor drawings. So whenever we use Inventor drawing, things like in this example, we are doing a section view. So a section view can easily be created in Inventor drawing, like just like that. So basically, you can just specify your section lines, and then it can automatically section for you. So like in this case here, what it shows on the screen now is the detail view. Okay, so we can create one detail view, maybe in the main view, or the front view. Just now it is too hidden, or maybe too small. We can make a detailed view of it, maybe give a bigger scale. Okay, and then we can put it or place it accordingly, and then we can do all the annotations like symbol, welding symbols, GDNTs, and so on. And what's most important, or what most interesting is, so with this process from parts assembly drawing, we are able to generate our part list almost instantly, because the process that we gone through earlier, so from parts to assembly, so all these informations are captured within Inventor. Okay, and then our Inventor can identify all the parts is used for inside the assembly, and then all can be extracted. If you have sub-assembly, sub-assembly also will be considered. Okay, and then the child of that sub-assembly will also be captured. Okay, so now I see that we're creating a balloon, okay, or a leader in a way. So with numbers, so Inventor automatically detects the parts number, okay, and then that numbers will be tallied back to the part list on the top right hand side over there. Okay, so that's the process. So that's the basically 2D to 3D conversion process. Okay, so after from AutoCAD, so we move into Inventor. So now you have some 3D models. So what you can do is, one more thing is called shape generator. So the feature name is called shape generator. Basically, it's material productivity. Okay, built in within Inventor. We're not talking about any plugins or Nastran. So this is just Inventor shape generator, where basically the purpose of this is to create lightweight design, okay, structurally efficient parts by optimizing material distributions based on the usage, real life usage. Okay, the overall very simple, very straightforward. Identify the parts, assign the materials you want to test, apply the constraint as if it will be used in real life. Okay, specify where is the preserved region you want to keep, define the planes, and just run on it, and then it will give all the it will give the suggestions, and we can accept or edit the proposed shapes. Okay, so now very simple. So this is one assembly. So let's say I want to lighten up one of the parts within this assembly. So let's say we are just going to use, we're going to simplify and lighten up these parts. Okay, we just one click shape generator. We specify the constraint as if how it will be used in real life. Okay, and then we identify or give the information, so the force informations. Okay, where is the force will be, how much is the force, in what angle is the force is coming. Okay, so after we identify all this, okay, so we just run the studies, and it will generate and give and suggest the shape. So in this case, the one in the mesh is the suggested shapes. Of course, it'll look a little bit organic, but we need to use that reference, and then we need to amend accordingly. So now what I'm doing here is I'm just editing it to make it more CNC machine friendly or laser cut machine friendly, so that it's easier to be cut. Okay, and then you don't have so much of organic shapes. Okay, and then from that original part, now we improve into this part. So within just one process. Okay, so this is the material productivity. So it's not just doing a stress test. So it can also suggest you the shapes, the best shapes for the design. Okay, so next, we're going to look into a factory floor optimizations. So how do we improve factory floor, factory processes? Okay, oops. Okay, so from the tools that we all know, that we always use for layout plan. So what spreadsheets, Excel, and so on. So now with AutoCAD to factory design utilities, or AutoCAD and then Inventor or to factory design utilities, we can integrate all these 2D drawings, 3D models of a building, and also with all the technical building equipments, all the machinery, all under one platform. So from here, we can generate, or we can control, and we can visual or view the factory more clearly. Okay, it's more easier to understand and easier to show to customer as well. Okay, so what is factory design utilities? So basically, it's a plugin that comes with product design and manufacturing collections. Okay, it doesn't sell separately. So basically, it works on top of AutoCAD, Inventor, and also Navisworks. So in a very easy explanation, so factory design utilities give Inventor and also AutoCAD the capabilities and also the extensive libraries of factory equipments. Okay, so all the so-called conveyors is there, robot arm is also available for usage for us to plan. Okay, so extensive libraries, so 2D layout into 3D model, so we can use all the common library for 2D and 3D. Basically, the 2D views and 3D models, they are sharing the same libraries. So whenever we add or edit the 2D layout, it will also update in the 3D models, in the 3D layout. If we make changes to the 3D models, it will also update to the 2D layout in AutoCAD. So basically, it's two ways. Okay. So inside factory design utilities comes is all the factory assets, all the equipments, asset training, material flow analysis. So we can plan for material or processes, smart connector to connect between one component and another. We can use all our prior work, so all our existing 2D drawings, 2D layout, we can use that. Okay, so we can convert many file format to add to our existing library in case we need to. We can create assets, new asset from existing block as well. Okay, so here is a quick way to explain. So this is in AutoCAD. On the right hand side is all the so-called asset libraries. Okay, all the factory asset. So now I'm adding in one back feeder, so one machines. Okay, and then I'm using all this the usual AutoCAD command: move, copy, rotate for placement. Okay, so I'm just placing these two equipment in a 2D drawings. So you can see there's one line in between. So next, I want to convert that polyline into a conveyor. So as simple as clicking that line, it auto convert that line into a conveyor. Okay, convert is asset change. Okay, you can see it automatically converted into a conveyor. Okay, so that's how easy it is to convert an existing lines or polylines into a factory asset. Okay, so now I'm adding in more things. Workbench over here. Okay, we can place accordingly. Okay, maybe we want to add some people. Okay, some human to indicate the positioning of that persons in that stations. Okay, and then we after save, and then I can sync and open it in Inventor. Okay, and then from that 2D layout earlier, when I sync to Inventor, it automatically generate a 3D model of that layout. Okay, that factory layout automatically created. Okay, with parts, and you can see also in Inventor we have access to the same asset library. So now I can insert my packaging machines. Okay, I just insert it into my Inventor over here, and I can place it, and I can connect it to the conveyor because it has its own smart connector. Okay, so after connected, okay, so just like that, we already connected one station to a conveyor. So maybe that's not enough. So maybe I want to make some changes to the conveyor. Okay, so I'm adding in a ball transfer. You can see it automatically changes, update the size. Okay, so when I measure, oh, there's a 100 cm of gap. Let me try to add one more conveyor in. Let's put it outside first. Okay, so all this asset is actually a very smart asset where we can amend or adjust the size. We can control the sizing. So from here, we can just adjust the size from the properties. It will auto update. And one more thing, if I move the connector, the conveyor just now automatically resize. Okay, it will automatically resize to fit or to be suitable to its connector. Okay, so now it is the same size. So we also have these so-called libraries for like robot arm. So we can place robot arm. Okay, we can control. We can also adjust robot arm to maybe to suit our needs. Okay, so like over here we can also add. So there's already like stations for robot arm. So let's just place the two robot arm over there. Okay, on top of adding in components or adding in equipments, what we can do also, we can also plan for the what you call it, area, the work area of the robot arm. Okay, so that we can identify what's the radius of that robot arm. Okay, so that we can make sure that we have enough gap so that the robot arm will not hit any maybe dividers or people when it's working. So we can also create that so that whenever we place in another stations, we can try to avoid the working area. Okay, so now let's add in our drawings. So we can also add our drawings in for the layout over here. So the layout that was originally from AutoCAD, we can place it. Okay, so now they are already aligned. So we have our so-called layout or our factory process there and our layout of the factory. Okay, and then maybe next step, we can go to the next area and create a layout for that area. Okay, so detailed design in 3D. So you can create 3D for free because the library comes together within the factory design utilities. We can analyze, okay, so let's say we go one step further. We can also analyze the processes, okay, optimize the material flow between one station to another, okay. Right. So next we look into cutting optimization. So what I'm sharing in this session today is all about AutoCAD to Inventor capability. So now we go into nesting. So from AutoCAD, so people are aware that they need to do cutting optimizations. Okay, so they need to plan for nesting. So manual way they use AutoCAD. Okay, and then move around, copy, rotate to get the positioning. But we can use Inventor nesting. So from AutoCAD, so when we use AutoCAD to create the parts in Inventor, it will then create the parts and then we can process that part into nesting. But inside Inventor nesting as well, we can use any DWG or AutoCAD drawings to be inserted, added into our nesting to run the simulations. Okay, so let's see. Okay, so let's say I'm adding in the same thing. So the same tank. Okay, so I can open it up. Okay, make sure I have the right defaults. Okay, so I need to make sure that we have opening so that we can flat pattern it. Okay, once we are able to flat pattern it, then only we can create a flat pattern and go towards nesting. Okay, so from here, we can save it to a flat pattern, a DXF or DWG, in case for future usage. So now let's just move to nesting. So Inventor nesting. Okay. So let's say over here that we want to go to nesting. So straight away I can select assembly. So I don't have to select part by part. I can just send the whole assembly to nesting and it will detect all the source file. Okay. So all the source file are available here. So I can just run the 3D model to generate the nesting. Okay. And then nesting will generate, and we can also add in a drawings. Okay, you can see the source there is AutoCAD DWG file. We can add AutoCAD DWG file as a source and we can use it to run our nesting study as well. Okay, so once we run our study, we can get our nesting efficiency and we can also export. Okay, so now just specify the materials. Once specify the materials, I can create the nesting and it will run the nesting. Okay, so this is the example. This is the examples of nesting efficiency. So like you can see over here that this is, you can see there's some empty spaces on top, which means that we so-called wasting that material on top. So what can we do? So there's a few ways to address this issue, and maybe we can add more components to be in this nesting, or we can reduce the size of raw materials. So in this way, we can get a better nesting efficiency. Okay, so it listed all the parts over there. So let's say I accept this. Okay, so I can run the cutting, so I can plan the cutting programs, so the laser cut programs from here as well. So we can run the simulations of the laser cut machines. Okay, so after we specify the machines, okay, we can simulate how it will be cut. Okay, understand that you probably already have your own cutting programs, okay, that comes with your machines. So what you can do also, let's say from nesting earlier, you can export that nesting result into DXF, and you can load your DXF file into your machines, your laser cut machine, so that your laser cut machine can program the cutting. Okay. So that's on. Okay, so let's see if there is any questions. Any question over here? Okay. All right, so that's okay. So let me just proceed. So if you use AutoCAD or you use Inventor, both you also have this capability where you can do a shared view. So basically, you can share your views, a view of your drawings of all your 3D models. Okay, so from here, you can either, if you use AutoCAD, I mean, you can access to your AutoCAD web to load your drawing to AutoCAD web, or from within AutoCAD directly, you can create a shared view. Okay, so if you have your phone with you, you can scan the QR code on the right hand side. This way you can experience how it looks like. Okay, so if not, this is an example. So let's say after I created that shared view, this is from a view from AutoCAD. So let's say after I create the shared views, okay, so of this drawing, so it's processing and it will show on the right hand side. Basically, you can just access the shared view from Collaborate tab and shared view. Okay, same goes with Inventor, Collaborate tab and shared view. Okay, so once we created the shared view, it will be uploaded into the cloud, and you are able to share it. So maybe okay, so every shared view, it will expire within 30 days, but no issue, because you can extend it before the 30 days. So let's say if the issue still is not solved within the 30 days, you can extend it. Okay, this is how it looks like in 2D. Okay, loading. Okay, so this is on the web browser. Okay, so all the layout will be automatically shared. You can see all the sheets is also available. Okay, so you need to plan your AutoCAD sheets, and also you can create a view in your AutoCAD. So that view will be placed here. Okay, so all like your favorite view will be available here. Okay, so if you are somehow required to work with BIM content or BIM format, okay, so usually, commonly, it's within these 5 manufacturing components. So building products or equipment. So if your company or your factory are doing this, you probably need to send your products to be used or to be consumed by BIM operator or architects. Okay, custom fabrication for buildings, building equipment and layout, a modular constructions, so IBS in a way, AC engineering for piping, tube and gas. You're probably required to send your product to be consumed by software like Revit, example. Okay, so if you look into deeper, okay, components like a curtain wall, steel structure, custom architecture component, prefab. So this is all a manufactured component that is used in a constructions. Okay, so basically, in a way, your product need to be used by constructions. So your product placement, sizing, and spec will probably need to fit into the building's requirements. So you will need the building to be used as reference for you to plan your products. Okay. So from let's say from AutoCAD, so after you make your component the 3D models, so next step is you want to use Revit files as reference, or you want to send your components or your products to be consumed by Revit. So very easy. So basically what you can do is from Inventor, you can generate, or you can you can generate a Revit family files, the RFA, or you can now export Inventor assembly into Revit files. So it can be used directly into Revit. Okay, so let's say our assembly or our components all very detailed to the bolt, screw, and nuts level, right? So if you want to send it to architect firm, they probably do not need all the details, so you can simplify down to the level of details that required by the contractor. Okay, so once you simplify, the size also will be lesser, lighter. So the process also very simple. So let's say within Inventor, you already have your components. Doesn't matter what components or what building equipments. So the process is pretty much similar. First, you simplify your products. Okay. So after you simplify your products, you need to identify where is the inlet, where is the outlet, what are the information that you need to give to your components or to your product, so that it will be whenever it will be used inside Revit, all the information is already relevant. Okay, like in this case, we can add to like sanitary, hot water, cold water. Okay, inlet, outlet, that's important. Specify the UCS, so where is the origins. So once all that done, you can create the OmniClass scale, assign the OmniClass specifications to our components, and what other properties is needed. Okay, so once this is done, so we can just export it to building components, Revit family, IFCs, or .idsk. Okay, this will be easily opened and used inside Revit. So now this is a Revit. So this is Revit. So now let's say I want to add, already add our component earlier. So you can see our components, our products over there already have inlet and outlet ready to be used. Okay, so that's the Revit interoperability. Okay, so if you are somehow having access to what do you call it, of this construction cloud, so maybe your main con give access to you, I mean assign a license to you. Okay, so you can also create a so-called something like a favorite view of that you can share. So from Revit, so this is the area that I want to share, this is the area that I'm going to use to place all my factory equipments. Okay, so now I can insert my factory equipments into the factory structures. Okay then, so any questions so far? So let's see if we have any questions. Okay, anything on the chat? Okay, all right. So if maybe you don't have a question now, so maybe after this you probably have some questions. So you can connect with me on LinkedIn. So you can find me on LinkedIn. You can go to our Facebook page called Data Design Solutions as well, or you can respond to the invitation emails. So whatever question that you have, so we will respond accordingly, okay, to answer your question. And we also have a series of webinars. So maybe we have one more, maybe within 2 weeks. Okay, so stay tuned and have a look at your email by then. Maybe even by next week, you receive some invitations. So if you're interested to join, so do register. Okay, so if you have no questions, then I will end the sessions.